So, we talked at the end of the last lesson about specific sequences, arithmetic sequences, and geometric. So, I know it looks like arithmetic, okay, but we're saying this as describing a sequence, so like an adjective. Not that I'm a good English teacher, but now we're using it like an adjective, so rather than a noun, so it's called an arithmetic sequence, okay? So, write the next two terms in the sequence. Even if it wasn't arithmetic, you want to look for a pattern, okay? So, negative 15 to negative 7 to 1 to 9, they're increasing. Remember what we did yesterday. If you take the second term and subtract the first, that would be negative 7 plus 15 is 8. 1 minus negative 7 is 8. 9 minus 1 is 8. So as long as you check it for a few, you're going to assume that the pattern continues in that way. So we keep adding 8. So that'll be 17 and then 25. Okay. Then next one, negative 7 minus negative 4 is like adding 4. So that would be adding 3. So, right, so negative 7 minus negative 4. Gets you, negative 3, I put down positive 3. So subtracting 3, because these are getting smaller, right? So then negative 10 minus negative 7 is like subtracting 3. This is like subtracting 3. So we keep subtracting 3. So that's negative 16, negative 19. Subtracting 3 is like adding a negative 3. Okay, and that's what we're going to end up doing for our general equations for these. So note that for each sequence, the difference between any two terms is the same value, right? So that's written out. A sequence is arithmetic if the difference between consecutive terms is a constant. This constant is called the common difference, and the letter D for difference is used. What is the 20th term of each sequence? It would be good to have a formula that relates each term to its term number. Okay, that's called the general term, rather than doing a recursive. Right? So we want to come up with a formula, and we started doing that yesterday. So complete the following table for this arithmetic sequence. So take a look at what we've shown here. We know we keep adding 8. So to get from the first term to the second, we add 1 8. Here we're adding 2 8s, or 1 to the previous. Here we're adding 3 8s, or 1 to the previous, and so on. So take a look. The end value here is 4. Term 4 has 3 8s added on to the first term. This term 3 has 2 8s added on. So T10 will be negative 15 plus 9 8s added on. Okay? And then Tn will be negative 15 plus n minus 1 times 8. It's always 1 less than the term number. And that really gives you your general term. We'd want to simplify it, but that's what you would get. Okay, so then complete the following for any arithmetic. So we don't pretend we don't know what the first term is or the common difference. So the first term is T1, then we add 1 common difference to get T3, we add 2 common differences to the first one. So always 1 less than the term number. So that means T10 will be T1 plus 9D, and the nth term will be T1 plus n minus 1 times D. And that's your general term. So this will be on your formula sheet, but you should try to memorize it, okay? Because it actually is helpful in other cases. Even if it's not specifically about a sequence, you may end up having a question that it helps to know that it's a sequence. Okay. So here is another sequence. Okay. It says for the arithmetic sequence, determine T35. Well, really, I'm going to do part B, the simplified expression, first, because it's actually easier that way. So our Tn, it's always lowercase t, subscript n, is equal to the first term plus n minus 1 times the common difference. So that's what we have to figure out. So negative 13 minus negative 20 ends up being plus 7. So we're adding 7 each time here. Okay, so this will be 7. Now whenever we show our general term, almost always, sometimes you don't have to simplify if it's not your final answer, but this is the final answer here. We're wanting the simplified expression. So collect like terms. Okay, so 7n minus 27. And then you can put your n term first, just like you always do. Okay, now to get T35 way faster, right? So 7 times 35 minus 27. So then order of operations, right? You want to multiply first. So that's what, 210 plus 35 is 245 minus 27 is 38, 18. You can check my math for you. 35 minus 27. Yeah. Okay, and then sometimes what you might want to do is figure out which term number a certain value is. So here we want to find n if we know what the term value is. Okay, so that means this is your Tn. So now 631 equals 7n minus 27. It's a working backwards type question. Okay, so then add 27 to both sides. And you should get a natural number. Okay, if you don't, then probably you did something wrong. Because you can't have a term number of like a half or a third or 0.32 or whatever. N's are natural numbers. Okay, so give you a sec to get caught up on that. Okay, so actually I just want to check here. Make sure, yeah, I thought there was another question. Okay, so example 2, determine a simplified expression for the general term of this sequence that has been graphed. So notice what the axes are. This is Tn, so that's your term value, and this is n, so that's the term number. So this means term 1 is 10, term 2 is 7, term 3 is 4, term 4 is 1, and term 5 is negative 2. Okay? So determine a simplified expression for the general term. And then do T30. So Tn, first term here is 10 plus n minus 1 times the common difference. So what's happening? Each time we're subtracting 3. If you were to find the slope between any 2 points, it would be minus 3 there to the right 1. So it's the same as the slope. Okay, so that's negative 3. Please make sure you put brackets around the negative 3, the d value if it's negative. Because if you don't, this is what it'll look like. And that does not look like multiplying. That looks like subtracting. Okay, so. All right, it says to determine a simplified expression, so we do need to collect like terms, expand and collect like terms. Then we want to find T30. Okay. So T30. And again, these are subscripts, so that 30 should be small. I know some of you have kind of big writing and aren't that clear. You really have to be careful so that it doesn't look like T30 same size, because that kind of means multiplication, right? Now we put in a big 30, right? But this is small. So that's negative 90 plus 13 is negative 77. Okay. Get caught up on that. Some more questions here. Take a look at this one. It says if 4 minus 2x, 3 minus x, 8 plus 3x are the first three terms of an arithmetic sequence, then determine the value of x and the value of the first three terms. So there's x's in there. Notice how you can't just add a number to go from the next one, from each consecutive term. So you have to think about, if they're arithmetic, then there's a common difference. So remember, the common difference is the difference between the second term and the first term. It's also the difference between the third term and the second term. And then it's got to be the same, right, if it's arithmetic. So let's get an expression for this. So we want to get rid of the brackets and collect like terms. So that's going to be x minus 1. And here, 8 plus 3x minus 3 plus x. So that's going to be 4x plus 5. So x minus 1 has to have the same value as 4x plus 5. So in order for this to be arithmetic. So now we solve that. So bring the x over, bring the 5 over. So x is negative 2. So we found the value of x and then put it back in to get what the terms are. So 4 minus 2 times negative 2 is like adding 4. So that's going to be 8. 3 minus negative 2 is like adding 2, so that'll be 5. 8 plus 3 times negative 2 is 2. Okay, so notice what's happening. We're subtracting 3 each time. So you know it's arithmetic, but you couldn't have figured that out from the terms originally, okay, without knowing what x was. Okay, so then question 4, determine how many terms are in the arithmetic sequence. This is kind of like the last one. If you know a term value, you can figure out what n is. But what do you need? You need the actual equation for the sequence. Okay, so here, this is starting at 182 and decreasing. And this is the last term of this particular. It's a finite sequence. It could go on forever, but we want to know how many terms in this. So what's happening each time? So our common difference here is negative 4, right? 178 minus 182 means we're subtracting 4, so that's negative 4. Our first term is 182, so our general term is negative 4 plus n minus 1 times switch those around, sorry. is Tn is our first term plus n minus 1 times negative 4. Okay. So now in this, you don't have to simplify it if you don't want to, because it's not asking you for the general term, it's asking you for the term number. So now, this is the term that we want to find n for. So we can enter that for Tn. If you want to expand out, you can, or you can actually subtract 182, divide by negative 4, but you could expand out in this step and then solve for n, right? So just, you're not asked for the simplified form, so you don't have to show it. So what's that going to be? 186, 196, so that's negative 200 equals negative 4n, so n equals 50. Okay. So there are 50 terms. Okay. Next one is actually a sequence question, but it doesn't sort of talk about it like that, but it says determine how many multiples of 6 are between 20 and 400. So I start writing out some multiples of 6 that are between 20 and 400. So 20 is not a multiple of 6. The first one between those two numbers is 24. Then the next one's 30. Then 36. Okay, they're multiples of 6, so that means you keep adding 6 each time. That's your common difference. Now, then figure out, is 400 a multiple of 6? Okay, so it is not, right? If you go 400 divided by 6, you get a decimal. What's the next lower value than 400 that's a multiple of 6? So try a few values, obviously even. Okay, and you get 396. Okay, so we have now just changed this. I think someone asked me a question here. Just give me a sec. And so now we want to know how many terms are in there, because those are all multiples of 6. So our first term is 24. First term is T1. So T1 is 24, D is 6. Okay, so I'll do it over here. So Tn equals the first term plus n minus 1 times 6. And again, we're not asked for the simplified form of the general term. We're just going to use it. So now we want to know what n is for 396. So 396 equals 24 plus 6n minus 6. So what's that? 18. So 396 minus 18 is 378 equals 6n. Divide by 6. 63. Oh, there's 7. N equals 63. Now, sometimes it'll give you between 1 and 400 or something like that. You could go between 1 and 400 and then subtract the multiples that are up until 20. So there's different ways of doing it. But this method is one that's using sequences and that general formula. You can answer this in different ways, but just wanted to practice, right? Okay, so a terminology that you may not have known is the terms between two non-consecutive terms of an arithmetic sequence are called arithmetic means. Determine the 4 arithmetic means. So normally the mean of a set of data, you add them up and divide by however many there are. So what is an arithmetic mean? It's the actual term value between two given ones. So what does this look like? If we're looking for 4 arithmetic means, this is negative 25 is the first term, then 1, 2, 3, 4, and then 70. That's what we're looking for. These are 4 arithmetic means. So it's not just random numbers. It has to really follow an arithmetic sequence, right? So, variety of ways of doing this. What you can do is use the formula. So in this case, really what we want to do is find the common difference, because then we can just add it, right? So this is n equals 1, 2, 3, 4, 5. This is n equals 6. So really here, T6 is negative 25 plus 6 minus 1 times the common difference. Okay, well, we know what T6 is. It's 70. 6 minus 1 is 5. So now you can find the common difference. So add 25, that'll be 95 equals 5D, and D equals, what's that, 19. So D is 19, so add that. So negative 25 plus 19 is negative 6, plus 19 is 13, plus 19 is 22, 32, plus 19 is 41, 51, plus 19 is 70. Okay. Now, that's using the formula. Again, what could you do? Think about, I'm just going to use a different color here. What are we doing here for those missing values? We're adding D, adding D, adding D. So if we're trying to find 4 arithmetic means, we're really adding 5 common differences to the first term to get the last term. So when we do that, really, so 5D, 5D, and so what that gives us when we add 5D is going to be the difference between 50 and negative 25. So 5D is going to be at, sorry, not 50, 70 minus negative 25. So 5D equals 95, so D equals 95 over 5, which is 19. So you could very well set it up like this. Okay, as long as there's some kind of work, if it's in a written response. And then, of course, you go back and actually give the 4 arithmetic means. Okay. So, this next one, if the first term and the 7th term of the arithmetic sequence are respectively 12 and negative 30, so I sometimes just like to write it out. So 12 is my first term. So you put a little T1 if you want. Then 2nd, 3rd, 4th, 5th, 6th, and there's my 7th. Okay. It says determine the 26th term. Well, again, it's kind of like the last one. We need to know what that common difference is, because we have the first term, but we don't know what the common difference is. So I'm going to do the same as previous, because I do have that first term there. Okay, so in this case, T7 is 12 plus 7 minus 1 times the common difference, and I know that value is negative 30. Okay, I know it should be negative because it starts, first term is positive and my seventh term is negative, and it's arithmetic, so it's got to be decreasing, adding a negative each time. You don't have to fill in these values because we're not asking you that. We now want to use that to get the 26th term. So Tn is the first term plus n minus 1 times negative 7, but we want to find the 26th term. Okay, so that's really 12 plus 25 times negative 7. You can do all of that in one step if you want. Okay, it should be more negative than negative 30. If you had not used the general formula there, then just like this one up here, you may have gone, okay, well, if I'm going from T1 to T7, that means I'm adding D 6 times. So 6D has to equal the difference between the last term and the first term. So then D is 42 over 6, which is negative 7. Okay? So that's really sort of a more logic. If you didn't know what the general term of an arithmetic sequence is, then that's what you do. Hi.
Hi. So using the green one would be okay. Using either method, right?
Yes.
Okay, cool. Thanks.
Yeah. Okay. And then 8, we've got an arithmetic sequence of giving you T12 and T13. Find the simplified form of the general term. So remember, for the general term, we need the first term. Okay, so here, if we've got consecutive terms, so D, if we subtract consecutive terms, we get D. So this will be 25 minus 30. That's negative 5. Okay. Now we're going to have to use one of those terms in order to find the first term. Okay, because we don't have enough information for the general term yet. So I'm going to use T12. So T12 is first term, T1, plus 12 minus 1 times the common difference. Now I'm going to put 30 in there. And you'll notice that then, so that's 11 times negative 5, which is negative 55. You can solve for T1. You know it should be bigger than T12 because the common difference is negative. And then we'll find our general term. So Tn is now 85 plus n minus 1 times negative 5. And it says simplified. Okay, so that one we actually had to figure out what T1 is. Okay, so just give me a sec. Okay. Now we have the 13th term and the 18th term. Determine the first two terms. Okay, so 50, oh gosh. So 54 is T13. T18 is not that far away, so that would be the 14th term, 15th term, 16th term, 17th term, 18th term. Okay. So this couple of choices. So you could now consider this to be the first term and figure out what your common difference is, just like we did in examples 6 and 7. You could solve a system, both with term 1's in it and the ends. I wouldn't do a system. What I would do is actually the green method for this. I call it green method, that alternative method. Because here, I'm adding D 1, 2, 3, 4, 5 times, right? 18 minus 13 is 5 times. Okay, so 1, 2, 3, 4, 5. So that means 5D has to be the difference between 15 and 54. So that is negative 40 over 5, which is negative 8. Okay. Again, I'm not asked for any of those missing terms. What I'm asked for is the first 2 terms. So now I want to figure out what T1 is. You can use either of those 2 terms and go, okay, well, T13 is T1 plus 13 minus 1 times negative 8. I know the value of T13 is 54. And 12 times negative 8 is negative 96, I think, right? 12 times negative 8 is negative 96. So 96 plus 54 is 150. You know T1 needs to be bigger than 54 because the common difference is negative. Okay? And so then T2 would be 8 less than that, 142. And yeah, you can check it. Do it the long way, right? Keep, in this case, going backwards, you would add 8 and keep going. Thing is, people, they lose track of how much they're adding. And I'm not sure if you can, let me see. Well, anyway, I'll show you afterwards. But basically, if you're writing a test in class and you're doing it not using a formula and you're just punching it into your calculator, this is what it sounds like, and it's really annoying to your neighbors. When you're adding the same number 100 billion times. So don't annoy your neighbors, right? Use the formulas. That's why they're there for you. And I think that was the last question. It was.